Moving on, there are two things which you should remember about cyclotron, which is the things which cyclotrons cannot do. What do you call this thing? These are limitations of cyclotron. Two most important cyclotronic limitations are, number one, that it cannot accelerate neutral particles, because remember the diagram we drew like this. We had a semi-metallic semicircular disc, right, and the charge was getting attracted due to this electric field in between from the center. So if the charge is already neutral, there will be no attraction inside any of the discs, so hence we cannot accelerate neutral charges. Number two, we cannot accelerate electrons. Now electron is a charged particle, but we cannot accelerate electrons using a cyclotron. Why? Okay, see this formula, m is equal to m naught upon under root 1 minus v square over c square. And another formula is that the time period, okay, I have not remembered the formulas, so I would again try to derive it fast. From this, r is mv upon qb, and time period is distance upon speed. Distance is 2 pi r upon speed is v. Instead of r, I am using mv upon qb. v goes, time period is 2 pi m upon qb. One, this formula and this formula. What are these two formulas related with? This is the time period for a particle to complete one circle inside a magnetic field, the time period of revolution, alright, which in this case is a constant, because with changing radius, with increasing radius and increasing velocity, okay, the velocity got increased, the radius got increased at every point. That is why the particle was able to gain more speed, more energy, more kinetic energy, and increase its radius, and at the end it was ejected from one of the windows. Now, time period remained constant every time. Whatever time was taken for the small circle was the same equal to the bigger circle, because the time period is independent of both radius and velocity here. So all these terms are constant. So the high frequency oscillator will do the perfect job for this. The moment the particle comes out of one of the D, it can change the polarity, particle will get attracted towards another D, and the moment it enters again the region between these two sides, this will again change the polarity. So cyclotronic frequency, the number of times particle is entering or exiting this field through this cyclotron, this high frequency oscillator, has to be very constant, and actually depends on this, right, time period of revolution. This is the formula for a particle, in which states that mass of a particle increases with increase in its velocity. According to this formula, if 1 upon v, what is 1 upon, if our electron, if we increase its velocity, electron is a very light particle, velocity gets increased instantaneously, due to which what will happen, okay, consider this, if v equal to c, what will happen? V equal to c, this becomes c square upon c square, which is 1, under root 1 minus 1 equal to 0, m naught upon 0 equal to infinite. So mass can increase infinite times. So obviously, if velocity is getting increased, its mass is going to increase, and when mass is going to increase, time period is going to increase. So it will go out of phase with the cyclotronic frequency, and hence it will not be able to accelerate completely or up to that extent which we want it to, or it can go out of phase. So these are two limitations of cyclotron. By the way, this was m naught upon infinity, which is equal to 0. We know that 1 upon any number is 0. I have already told you this thing. Why 1 upon 0 is equal to infinite? Is there any logic behind? Don't bug your teachers up with this sort of things, but you should know the logic behind it. 1 upon 0, nothing, is infinite. See, I'll tell you a very brief explanation. I have also already given this explanation long time back, but I'll do it again. I am going from 0.1 and I'll go towards 0. 1 upon 0.01. These are all zeros, okay? Don't mind my writing. Please excuse my writing. So this value is 1 upon 1 by 10, which is 10. This value is 1 upon 1 by 1000, which is equal to 1000. So the closer you go towards 0, your answer will keep on increasing. That means when you reach 0, your answer will be the maximum, which is infinite. So this is the logic behind why anything divided by 0 is infinite. Alright, so let's summarize few formulas which we know right now up to this point, and on the basis of that, let's do some more expressions in your magnetic field, which is magnetic effects of current. What are the things left for us to do? We have to find out the force. Okay, we just found out what? These were all related with the force acting on one charge, which is moving in a magnetic field. But when current flows in a conductor, current is flow of lot of charges, lot of electrons. So that means if that whole conductor is placed in a magnetic field, the accumulative force from each of the charge will give a big force on whole conductor, due to which the whole conductor will experience the force. That is what our next topic is. Rewind the statement, like pause the video, rewind the statement, listen again, you will get my point. That is force, write down the the heading, force on a current carrying wire placed in a magnetic field. In a magnetic field. What is the expression? Consider this to be a uniform magnetic field, okay, and my wire is placed like this. This is my current carrying conductor. I don't have to repeat that force field current, the direction, left hand rule direction is still applicable on force. So current is flowing in this side, field is vertically inwards, current is in this direction, so force is vertically upwards, like this side. So this conductor is flowing in this direction, it will go like this, upwards. Okay. So how should we go about expression? If you have forgot about introductory lines, I'll keep picking up. Introductory lines are always to be written in front of or before derivation, and this help to summarize what are you going to do. Most of the times it is just assumptions. Let I be the current flowing through a conductor having charge density small n, like, alright, and what else? Placed in a uniform magnetic field B. Write such statement. Let small f be the force which is acting on each particle, each charge, because if you expand this wire, it will be full of a lot of charged particles which are moving in random directions due to electric field setup, which is causing the current to flow. But they are all experiencing some force due to they are placed in magnetic field, and hence accumulative force will be on the whole conductor. So let small f be the force on each charge, then small f will be equal to QVB, right, or QVB sin theta. Guys, I can do this same expression in two different ways in scalar and vector format. So see, I am using the scalar. You can do any one in your paper and you will still get the full marks, but I would like to explain you both. Instead of Q, I would be writing minus E because we are vector. Q minus E, V, which velocity we are talking about? Charges are moving with drift velocity. So VD cross B, right? And I have taken the perpendicular direction of magnetic field. Sin theta is sin 90, sin 90 is 1. So I don't have to write sin theta everywhere, right? So this is the point. Instead of Q, I should be writing E because that is the charge we are talking about, one charge. If N is total number of charge which are moving in the conductor right now, then total force which is acting on this conductor will be capital F, that will be equal to capital N into small f, right? But how would we know the value of small f? Sorry, capital N. Capital N is total number of charged particles which are moving inside this conductor, which we cannot figure out, which we cannot know. So to know that, we have another term which is called charge density, and it is what? Small n. This is what? Total number of charge flowing per unit volume, right? So small n is n upon area of cross section into length, that is volume. Total is small n A L. So using that thing, small n A L into F, I'll do this thing later on. So n A L, instead of F I'm using E VD B, N E, okay, let me use this color, N E A and VD. What does this make? Remember current electricity, I equal to N E A V D. So these things become I and you have L B. You can memorize this formula like ILB, or easier way is F is equal to BIL. If you don't want to remove sine theta from here, drag it along everywhere and it will become ILB sine theta. So now it gives you an idea that it can be IL cross B, because length, the vector term here is diff velocity, right? So it is included in the length, so it will be, current is a scalar, so length and the magnetic field will be the vector quantities included here. You want me to do this? Let's do it fast. Instead of small capital N A L, that's it, into this is minus E VD cross B. So this becomes this and this becomes I, and drift velocity is negative of current, so minus sign goes, so I am left with I L cross B. This is my the same formula in vector form, and this is in scalar form. Note it down please, just a second, no, note it down.